Hello everyone, my name is KabirKhanuja. I'm an engineering student pursuing computer science, and here's my presentation about something I'm not only vehement about, but also kind of technology that has helped me with the tasks related to Liquid Galaxy with its functionality. Now we had a task 2 in which we were required to create a Flutter app which had an ability to send KMLs via the pyramid. So we needed to send the pyramid KML and the logo on the screen, on the rigs, right? Or display it basically on the Google Earth. And then after displaying that, it also had a functionality to remove them through just one click. So you send them, you don't want them, you click the button to remove them, it gets cleared altogether. And then it can be sent back and removed again with a click. Oh, how all of this was possible? This was possible because of a cryptographic network protocol, that is SSH. So that's the topic for today. SSH as the control backbone of Liquid Galaxy. But to start with, what exactly is SSH? You need to understand these fancy words, the protocol, SSH, how is it able to interact, how things are sent. So SSH basically is a secure shell network protocol that establishes encrypted connections between computers for secure remote access. Now we had our LG app, but there are tablets in the centers to control all those rigs. And to control all those rigs, you need some set of rules that are tailored by SSH. Now, a protocol basically is a set of rules or instructions. It's something that I learned in computer networks. It's a subject in computer science. And what SSH does is to bring in some complex and strong encryption algorithms that in turn lets file transfer securely over a network which might not be safe. Supposedly, we'll take an example. Here's my phone, and there's another phone or my friend's phone, and I want to send certain files to him or her. Now, the files would be transferred through a pathway that has been defined. Only then I'm able to send those files. Now, in this whole process of sending the files from point A to point B, what if there are some people who intervene the process and manipulate those files, or even take those files for that matter, if we are considering privacy? So hence we say that public networks aren't safe, because if you get connected to their Wi-Fi, then people can access your machine through the network because we have defined a pathway towards your machine. So there should be something concrete, like a tunnel that has to build for the client and the server through a combination of keys. Now, keys are important because no one can enter our home directly. The people who have that access to the key can only enter our home. So let's understand the keys further in the presentation. But now it's important to know that how the security works. So now we know for a fact that if we build like a secure tunnel from point A to point B, it is secured through SSH, because SSH creates those strong set of instructions which has a strong encryption algorithms that won't let other intruders come in. So now that we have established the whole tunnel, now how does supposedly my phone know that this file has to be sent to point B? Like, how does it know the pathway? Even though tunnel is established, it wouldn't know because you don't have those endpoints defined. So again, that's the question that how does the traffic know its destination? And the answer is port 20. Oh, wait, this is not port 22. This is, sorry. Okay, yeah, that was a mistake. This is port 22. So port 22 is the answer to that question. It's like a port. So port 22 basically is a default TCP designated for our SSH. Now, what is TCP? Again, some buzzwords. So TCP basically is a transmission control protocol. Now what happens is when you send info from the client to the server or from the server to the client, a connection has to be established where they both say that the message is received. So if I'm sending the file to my friend, and then my friend would, come back to me, would tell me that, okay, the file has been sent. He would give me a confirmation message. So if I have to send someone a PDF of my notes, so they'd say, okay, it's received. I got the message, right? So that handshake should happen. That, something that then establishes that connection, that recheck, that yes, the message has been received, and this tunnel is now something, a pathway that can be used to send the messages, right? So that confirmation, that rechecking is important here. So in a Liquid Galaxy SSH, Liquid Galaxy uses basically this SSH through a meticulous TCP. So the master node never has to guess what the slave got a particular command or no. So it knows for a fact that the slave are getting those KMLs, are getting those set of instructions, and it has arrived perfectly because we have set that SSH session. It knows that it is confirmed to them because we have set up a TCP handshake, right? So the master node doesn't have to know, or doesn't have to, cross check again and again, because we have already initialized a SSH session using TCP, that is port 22. Though I can see those SFTP client and SFTP server in that presentation. So let's understand what is that. Why is it written the way it is? So imagine you have some KMLs to send to the Google Earth sitting on the master node's hard drive. Now you need to copy those exact files onto the hard drives of slave 1, slave 2, slave 3, slave 4, and all the slaves that are there, so that they can be displayed as new content. Now you definitely don't want to, open up some new insecure side door and move things around. Now this is where SFTP steps in. It stands for SSH File Transfer Protocol. Now SSH is a secure concrete tunnel, as I mentioned, connecting, say, your buildings. And SFTP is like the train that runs inside the same tunnel. We did discuss about the security of the tunnel, but now we want to know that how are the messages being transferred. So there should be a communicator who's actually sending from point A to point B inside that tunnel, right? So SSH is the tunnel, but the train inside is your SFTP. And because SFTP travels through the existing SS tunnel that we have established, it uses the same security that we have already set up. So it goes to the same port 22 door, and it uses the same keys to get in, so that you don't have to build new infrastructure for every new file. So if I've sent the pyramid KML in the first instance, and then I want to, send another monument, right? I want to send a Taj Mahal, right? For that, I don't really have to create the tunnel again, because a pathway has already been established. There are doors, that's port 22, and there are keys to open and close them. So in Liquid Galaxy, whenever the master needs to push new content files to the screens, it just loads those files onto the SFTP train and sends it zipping down the secure tunnel to offload all the goods onto the slave. So this is the master slave architecture that I was referring to. Now this would make things a little clear. It's a very famous master slave architecture because it is like the cornerstone for Liquid Galaxy. So the master is the master node. It acts as a brain, receiving all the web server commands and then deciding and exactly what the entire cluster should display. The whole thing should display. I'll even show the image for that matter. So this is basically those rigs, and then there's a tablet that's there. So point being, the master node is like the brain, right? And then there are those slave 1 and slave 2, the slave nodes. Those act like the muscles, receiving all the synchronized instructions via the tunnel that is SSH, to render any kind of file or a specific portion of the visual that we have sent, that too seamlessly. Now, this particular hierarchy that you can observe, that hierarchy ensures that a collection of separate computers would then work as a single unit, right? So when you see this image, you can kind of observe that it's the same scenic view that is reflected, but in a way that it acts like a same unit. It feels like a one gigantic screen instead of single screens that are set up there. And that's the reason SSH is pretty helpful to then establish all those tunnels so that you can know it works in sync, right? So yeah, this is basically the actual infrastructure where there are multiple screens and there's a tablet as well that I mentioned, right? It was our LG app for us through which we could control different things. But what if you wanna restart a particular machine, or you just wanna restart them all because you have had an update that you wanna then make reflect it there? Would you actually go to every single screen and restart them? It's a question that do I walk to every single computer and then restart it? That's not feasible. I mean, it's gonna be a waste of time going to all of those computers and then restarting them. So what's the solution? So here's where the command relay kicks in. Oh, what is command relay? Okay, so command relay, as mentioned, is like the technical nervous system of Liquid Galaxy. It acts as the bridge between our input and the cluster's response over that. So this is basically a communication architecture. Now the working of it consists of 3 to 4 main things. That is trigger, reception, broadcasting, and execution. Now what is trigger? There's a command written over there, relaunch. Let's take that for instance. So you perform an action on your tablet, you go here, you're like, relaunch the whole system. Now the tablet sends this command solely to the master node, which is the reception that happens between the master node and the tablet. Now this has to be broadcasted in every single slave. So the master node uses its established SSH tunnel that we have already done to relay that relaunch command to every single slave's IP address and all together at once, so that it's going to get reflected every single where that particular command. And then happens the last part, that is execution. So each slave node receives the command through port 22 because that's the door, and then it executes locally, ensuring that complete Galaxy system is going to get updated in harmony. It's going to get in sync, and again it's going to get updated in harmony. But when we talk about harmony, we also talk about automation, because it's not as easy as it seems till now. Now this is the really technical, in-depth part of it, where you can understand that how these things actually work. And how things work smoothly is because of passwordless authentication. So when machines in a LG rig, they communicate using SSH, there should be a way that, again, when you talk about sending a KML, now KML would be reflected in the master node, but then as you zoom in, the parts of it would be also divided in the subsequent screens. So those parts, how will it get reflected without those screens knowing that is it secure or no? So when you're sending information from the master node to the slaves, you need to ensure that information is legitimate. Like, again, as I said, is it the same KML that is reflecting on all slaves or no? So in that process of assurance, the access to all the slaves, it can be done using one of the methods. That whenever you're sending a file to all those slaves, a password has to be entered. right? When you access your Google Drive, okay, you first log in into your account and only then you're able to access that Google Drive and only then you're able to send the files. So that password thingy can be one of the solutions. But then every time you send a new KML, is it efficient that you go to every single screen and then you enter your password? And then that lets you update those KML. It isn't efficient, right? To solve that problem, we have keys. But again, those just entering the password and then updating those KMLs would break the automation, right? So these keys is the solution to not going to all those screens again and again, entering that password, those asymmetric keys. So wait, I'll just show you the lock-in key system and then we'll get back to this. So the answer to not break the automation, the harmony that we observed here, we need the lock-in key system. Now what happens in lock-in key? So looking at the lock-in key system, our LG is able to send all those KMLs and have everything smoothly because of a real-time thingy that happens, and that is enabled by lock-in key. Now imagine you have that master node. So there's a master node here, okay? So imagine the node in the middle, the master node, that needs to send a relaunch command to all the screens. So instead of just shouting that command over the network where everyone could hear, the master uses a public key because you want that all those screens should be restarted as well. Hence, you would have a key that is the public key that would let all the screens know that, hey, we need a relaunch. So using that, all those screens get the message and they encrypt it successfully. Now, as you can see in the center of the diagram, there's a encrypted message symbol there, right? So that command, the encrypted message command, is a scrambled box that is totally unreachable to anyone else on that network, on that IP. And when this package hits the receiver, which is our slave node, the slave uses its own private key, and that only key is in the existence that fits that specific lock to decrypt and read the original message. Okay, so there are two kinds of keys. There's a public key and there's a private key, right? The master node, which is the main node, it has the private key. And we leave all the public keys to the slaves. Because the main info, that is the relaunch thingy, that is completely private. That has nothing to do with other people's IPs, right? It is something that is secure. But once that is sent to the master node, and once we need to then reflect that changes on other nodes, we need it to make it public for them to access it. So we leave the public key in all our slaves as like the golden tickets. So when the master connects, the slaves verifies the identity cryptographically, and instead of asking for a password through keys, it has the access to the lock-in key system. And in order to enable that lock-in key system, we have that command that is that SSH keygen. So when we run that SSH keygen, it creates a lock-in key system inherently. And this allows the master to log in instantly, and then it secures the whole thing, which in turn enables a seamless automation in Liquid Galaxy, which is something Liquid Galaxy is known for. So that's the thing with lock and key, how it works together in order to secure the whole thing and then even send the messages. So if it wouldn't have been for the lock and key, we had to always go to a particular rig and then enter the password manually and then accept that yes, we do want that particular KML to be reflected on it. So lock and key works in a way that your private key would be in the master node and your public key would be in all the slave nodes, and that's how it's gonna work. But now, as we dived a little bit deep into the code side of it, let's now understand what the CAD developer has to say about Dart SS2. So it's not only about these things we now need to implement, as well as we first got a glimpse of what SSH keygen is. So now we need to know how do you initialize those clients in our LG app. Okay, so this is my VS Code, and this is the code base for the LG controller app that I created. And this file, LG service.dart, it's a main boss. It's a main boss for the SSH tunnel that we configured, because it has the core logic which is needed to send those files. So it's the connection that has been established, that we gotta establish. It hasn't been established yet. And how are we gonna establish the connection? It's via the Dart SSH2 file, that package. Now, what is that? It basically is a package. It's a library of Dart that enables Flutter to interact with all the remote machines. Because now I gotta send certain Linux commands, right, on the master node, LG master node, and I also gotta send certain files that are the KMLs. So KMLs are only gonna be sent using a client that is SSH file transfer protocol, SFTP, right? So let's start with first importing the package. So we'll import it. That is package Dart SS. No, we don't want the source. We want the Dart SSH2 to be there. To Dart. Then okay. So it has been imported successfully. Okay. Now we need to initialize the client here, right? Because it's important that every object of LG SSH service must store a configurable or a configuration object, right? So we'll create a variable first, that is your it's config, right? So because we need that configuration to be there, so we need to create a variable that appends to config. Okay, so now we have created a variable. Now we have to even initialize the client, right? And that client would then store that information of the connection. So it has to be nullable, right? So in order for it to be nullable, we'll use the question mark thingy, which is generally used in Dart. So client, and then this has been created as well. Okay, so for this class, that is LG SSH service, we also need an object. We also need a constructor, which would then will be able to access the config, right? So let's go and create a constructor for LG SSH service, and we'll use the this keyword because we need that config. And okay, so using this, see, every connection or every logic that I've written is now streamlined because of my initialization of the client, because I uploaded the package which gives certain sets of tools. So this way we are able to set up the whole configuration to send all the remote commands, all the files that I mentioned. Okay, so that was the basic implementation of how the Dart SSH2 works, how it is there in the code, how you initialize the client. But it isn't the end yet. There's one last step, and that is about the keys. So in the conclusion, I will tell that how those keys again operate. There's a really nice analogy, but before that we gotta learn certain best practices. Now, what are these best practices? So basically, those keys are also needed to be stored somewhere. And when, okay, now it's an asymmetric kind of a relation, right? So here, even I have to store those keys, because then I'm gonna run my Flutter app, and then I'm gonna have all those things go in the server, right? So those keys are needed to be stored somewhere, and they aren't like just those normal passwords. They're pretty encrypted, so they have a particular kind of directory where they are stored and in a kind of format they are stored. So the best practices to store them are using 700 and 600 rule. Now what are these? So a user can, read, write, or execute certain files, well, all the files for that matter. So a user can have that ability that they can only write a file. I mean, they can only read a file, but they can't write, or they can write and read, but they can't execute. So this ability or disability can be given or taken using chmod commands that are in, Bash, Linux, anything, right? These chmod commands are responsible for the reading and writing of a particular directory or a file. So chmod 700 basically gives a directory or a file the ability that an owner can read, write, and execute, whereas the chmod 600 just gives the ability to read and write. Now, your keys are stored in a directory that is /ssh directory, and the keys, okay, this is a directory, and then there are keys inside it. So those keys are stored with chmod 600, and the directory in itself is gonna be stored using the permission chmod 700. And if you don't practice this, you are pretty vulnerable for certain kinds of attacks if your key gets leaked. And also now the package inherently has those functionalities that it won't accept it unless and until you give this kind of a permission, so that everyone follows the best practice. So concluding this all, okay, now this is the kind of analogy that I wanted to provide, right? The liquid galaxy analogy. So basically, liquid galaxy architecture functions as a unified, technical nervous system where SSH, which we talked about, serves as the vital glue connecting the cluster. You can see the bluish or purplish kind of a glue. These are the slaves. Those all form a cluster. So they are tightly glued using something that is called as SSH that we discussed, right? And this whole setup is leveraged using the master slave hierarchy, which allows a single master node to act as a central proxy that relays commands from a controller to all the slaves that would then, display everything simultaneously. And by utilizing this, the public key and the private key, these are the key pairs, so utilizing these key pairs for passwordless authentication, the system removes the complete barrier of the manual logins, which in turn ensures that every door, now door is your port 22, it ensures that the cluster opens instantly for perfect and seamless synchronized automation. So that's the whole summary of this analogy. I hope you all understood that how this whole thing works through this analogy of tunnel, of the doors, of the slaves, of the glue, of the keys and everything, and why SSH in the end is very important. Thank you. Signing off.